Hi class, in this lesson we're going to take a look at synthetic division. And what synthetic division does is it takes two polynomials and divides them without having to use long division. And trust me, it's a lot nicer than doing long division. But in order to do synthetic division, we have to have perfect descending order. For both polynomials. In other words, if you take a look at this first polynomial, we've got 3x to the third minus 2x plus 5. Now, it's got to be perfect descending order. And what that means is we can't miss any exponents. For example, we go 3, blank, 1, none on the x. In other words, there's an x to a 0 right there. So what that means is we're missing one right here, and we're missing an x squared. So wherever you're missing something, we have to fill it in. So we need to rewrite this as 3x to the third plus 0x squared, and then plus minus 2x plus 5. Okay, so that's the first thing we need to do. And then this second one is just x to the first power and then x to the no power, so we don't have to worry about that one. That one's good to go. So we're trying to divide these. In other words, we're taking this first polynomial and dividing it by x minus 3. Okay, but we're not going to write it that way. Another way that we could have done it, we could have written it like this, divided by x minus 3. But that's long division. We don't want to do long division. What we are doing is synthetic division, which will take our coefficients. Now, coefficients are the numbers in front of the variables, and just writes them without the variables. So I'm just going to bring them down. 3, 0, negative 2, and 5. So you can see these numbers coming down, no variables. Okay? And now what we'll do is we take this number, this second polynomial, it's a binomial, and we just take this 3. Ignore the x, but whenever we have x, minus, or plus, or whatever number, you take this number, you change its sign, make it a positive 3, and put a little box around it like that. Okay? This is just how you do synthetic division, so try to get used to the form here. And then what we're going to do is we draw a math line, giving ourselves a little bit of space right in this area for extra numbers. Now what we do is we take this 3 and we bring it down. That's our first setup in doing synthetic division. And now what you're supposed to do synthetic division is take this number here, whatever comes down in this area, and we're going to multiply it by the number on the outside. The result is going to be 9. So I take that 3 and multiplied it by this 3, and I get 9. I write that right here. Okay? So again, I took the 3, times it by this 3, and that gave me my 9 that I put right there. Okay? Now, the next step is to take these two numbers, the 0 and the 9, and just add them. And that gives me 9. Okay? Now your next step is to take the 9 and times it by the 3 over here. 9 times 3 should give you 27. The 27 goes right here. Okay? Now again, we do the next step, which is to add these numbers. So we just add them. And this gives us 25. Okay? And we just keep doing the same cycle. So now I take the 25 and I times it by the 3 out in front. The result is 75. That's going to go over here. Okay? So I'll put 75 here. And then to finish, you just add the last column, which is going to be 80. Okay? Now, in your final column, always put another box around this final column. This final column is your remainder. Okay? If I could fit remainder. What that is if it's a 0, it means you have no remainder. If it's a 0 right there, so if this part right here is a 0, okay, if this is a 0, it means it went in even. Well, this number, what I'm talking about went in evenly, is that x minus 3 would have went into this evenly. Well, it didn't go in evenly. There's a remainder of 80. So that means it's just like if I took 3 and divided it by 2, I'd have a remainder of 1, okay, after dividing. Same thing here, it doesn't go in evenly, so there's a remainder, okay? So that's how synthetic division works. Now, to finish, your final step is you're supposed to replace your variables. Notice at the beginning I took out my variables. I had x to the third, x squared, and x, and then no x. And now I don't have any variables. Now, the way to do it is you start from the right, and you have, starts out with no x. In other words, it's x to the 0 power. Okay, or just no x is easier. Then you put an x to the first power on the next number, and then put an x to the second power on the following one. And if there's any more numbers over here, I'd put x to the third, x to the fourth. However many you had, you would just keep putting your x's out in front. Okay, so what this means is my final answer is 3x squared plus 9x plus 25. So this is the result, missing, plus the remainder, I almost forgot that, plus the 80, but I don't put plus 80, it's 80 over x minus 3. This is your final answer from dividing x minus 3 into the 3x to the third power minus 2x plus 5. Okay, now let me go back to the solution. The reason I put my remainder like this is because if I was to take like 3 and divide it by 2, it goes in once, and then you would do 2, and you'd subtract, and you end up with 1. So what we do is we say it's 1 and a remainder of 1. Well, we learned to deal with this, to write it as a mixed number, you would say 1, and then you take your remainder of your 1 and put it over what you were dividing by, the 2. So it's 1 and a half. That's what I did right here. I put this back over the x minus 3 because it didn't go in evenly. Alright? Well, let's go ahead and take a look at another example and try to get the pattern to go a little more smoothly. So this time the original problem is written differently, and you'll see it a few different ways in your in the lab, but it all means use long division and divide. Okay, so I've got this top thing here is being divided by x plus 2. So first thing I'm supposed to check is, do I have perfect descending order? 2, 1, none. Yes, it's descending order, so I'm good to go. So I just need to take this first equation, or polynomial, and write the coefficients. 5, 16, 15. Okay? And then I take this bottom one, the one that's dividing, okay, the denominator, and take my sign and change it. Okay, so this is my x plus 2, so I make it a negative 2. Okay? Now, I draw my math line, give myself a little space to bring down the 5. So I bring it down. Then you take your 5 and you times it by negative 2. Okay? And that answer is going to be negative 10, which goes right here. Then you add the 16 and the negative 10 to get 6. Then you take your 6 and times it by negative 2, which should give you negative 12. So I put negative 12 right here. And then I go ahead and add, and I should get 3. So now I want to go ahead and write my answer by starting off with a box right here, because this is your remainder. Okay? Then this is x to the 0, in other words, no x, and this is x to the first power. Okay? So my answer is 5x plus 6 plus my remainder is 3, but I want to put it over what I was dividing by, which was technically x plus 2. So this is how you do synthetic division. Second example.